As we begin Chapter 5, we get back into a lot of definitions. These definitions are important to know because they help you understand the concepts and applications that we're trying to do in this chapter. So make sure you spend some time and really define in your own words what these definitions are and how we use these items. We'll go through some of these definitions while we're working through the problems. There are a couple of equations that you need to know for this chapter. That total cost equation, I'm going to give you two different ways to look at this. First, we know that our total cost is equal to our fixed cost plus any of our variable costs. Keep this in mind as we look to make sure that we're applying that properly in some of the other equations here. Another way we look at this, especially when we're looking at graphing and slopes, is y equals mx plus b, where this is our variable cost, this is our fixed cost, and that y is our total cost. So keep that in mind. It'll help you through some of these other situations. Another equation that we're going to be using is to calculate the high-low cost estimation. What this is a set of data given to us, and what we want to do is pull out those variable costs and pull out those fixed costs. The first thing we need to do this is find what that variable cost is. To do that, we're going to take our change. If you haven't gotten to some of the other courses yet, that little triangle means change. You're going to take your change in cost over your change in activity. And this is going to be equal your variable cost per unit. And when you're looking to find the change in cost and the change in activity, you're looking at the highest point in the graph and the lowest point in the graph. Hence the name high-low cost estimation. So you're going to take the difference in the highest cost, the difference in the lowest cost over the difference between the high and low activity. Once we have that variable cost per unit, our goal is to figure out what our fixed costs are. To do that, we know that our fixed costs are equal to our total cost minus our variable cost. And if we know our variable cost from step 1, we can fill that in. We know our total cost because that's given to us. So then we can figure out what our fixed cost is. So what we're going to do is find this variable cost. We're going to use the high point, plug it into this new equation to find our fixed cost, and that will give us what our fixed cost is, and we can go back to our original y equals mx plus b, and we can fill in the fixed cost, we can fill in our variable cost per unit, and then we know at any given level of activity what our total costs are going to be. So there's a couple new concepts introduced in this chapter. I'm going to walk you through a couple of different things, and some of it is probably easier than it looks. It's just the way that they're setting it up, so I want to walk you through that. The first thing we're going to look at is 5-34. In 5-34, they give us some data, how many of the production hours are billable, what our fixed overhead is, and then they want you to kind of build out what does year 2 look like if production hours are expected to be 20,000 instead of 25,000. And what is the estimated direct materials, direct labor, variable overhead, and fixed overhead. We're going to break that down for our planning purposes and for year 2. So to do this, we're going to start by building out just a chart to make it a little bit simpler. We have our cost here. We're going to have what does our year one look like? What's that change in cost from year one? That's going to give us our year two cost. And then we're going to look at our volume, our growth in volume. And that's just looking at what is the change from last year to this year in those billable hours. And that will give us our year two cost. And we're going to look at this again by direct materials. We'll look at direct labor. We'll look at variable overhead. And then we'll look at our fixed overhead and our total. So the first thing I'm going to do is just pull down all that information I already know. I know my materials are $40,000 in year one. That actually looks like a V. That should be an L. So I'm going to correct that for you so you're not confused. My direct labor is $2.9 million. My variable overhead, if my fixed overhead is $700,000, my total overhead is 1.3. That means my variable overhead must be $600,000. And then I can get a total cost of 4,240. Now if I read through some of this information, it says that materials and supply costs are expected to increase by 10% for materials. Direct labor is going to increase by 5%, and variable overhead will remain the same. Fixed overhead is expected to increase by 5%. So what I can do when I look at those change in costs are go back in and input a percentage reflecting these changes. Since direct materials are going to change by 10% in year two, I would spend 110% of year one cost. For direct labor, it increases by 5%. Variable overhead is going to stay the same, and fixed overhead is going to increase by 5%. All I'm going to do is multiply this out to get what my year two cost would be. So that's 44,345. 600,000 because that doesn't change, and 735. Now remember, this is year two cost based on that 25,000 billable hours. But we know that year two production is only looking at 20,000 hours. So we have to reflect that change. To do that, I'm just going to put that into a percentage, saying I only want 20,000 out of the 25,000 for each category. Except for fixed costs. Fixed costs are going to stay the same. They're fixed. They're not based on level of activity. So again, I multiply this out, and I'm going to come up with my actual year two cost at 20,000 billable hours. If I multiply that out, $480. I already did all this math to save some time during the video, so don't think I'm that smart and I can do that all in my head. If I add down, it's 3,686,200. So now the second part of this, so this part right here is giving you that cost information for year 2 based on that 20,000 hours. The second part of this, they want to determine the total cost per billable hour for year 1 and for year 2. Well, that's easy to do. We just want to know how much is it costing per hour. So for year 1, I take those total cost, I divide it by how many hours, and I get 169.60. In year 2, I'm going to do the same. I take 3,686, 200. Here I only have 20,000 billable hours. Therefore, my total is 184.31. So that's just one way you can set it up. Obviously, there's other ways to do it, but this really lays it out, shows you what's happening from year to year, and also shows you that difference in billable hours and how that affects your total costs. Now moving forward, we're going to look at that high-low method. This is 5-36. If you recall, I'll come back here and I'm going to grab those equations. We're going to have to this is a kind of a two-part thing. First, I'm going to find those total fixed costs. Then I'm going to plug, or total variable cost. Then I'm going to plug that in and find my total fixed cost. So the first thing I have to do is come up here and I'm going to find that highest point and that lowest point. So if I go in and I look at my activity, easy, this is my highest point. I'll do this again. Maybe I'll find a different color. And I'm going to look for my lowest point, which is right here. That's my low point. So what I'll do with this information is plug it in to my first equation here to find that change in cost over change in activity. So my total cost is 564,210. I'm going to subtract out the 503,775, and I'm going to put that over my change in activity. 8020 minus 6490. And again, this is going to give me my variable cost per unit. So my variable cost per unit is going to be, let me find that. I didn't do that one fast enough. $39.50. That's my variable cost. Now that I have that, I'm going to go ahead and bring that down and plug it into my equation here. So I'm going to take this $39.50, I'm going to bring it down here, and I'm going to say my variable cost times X minus my total cost is equal to my fixed cost. Again, this was $39.50, just to show you. Now I erase the 5. Alright, so now I can use, again, I'm going to go ahead and try to use the highest point, and I'm going to plug that into my information so that I can then determine what my fixed costs are. My total cost is 564,210 minus my variable cost, which is $39.50 times the activity, which is 8020. And if I multiply this out, I have 564,210 210 minus 316, 790 equals my fixed cost. Do a little bit more math. Find out my total fixed costs are 247, 420. So now what I can do with this is plug this into that total cost equation. Make that purple. Remember my total cost equation equals fixed costs, or let me write this a different way. Variable cost plus fixed cost, or y equals mx plus b. I can plug this in, and the point then is to say at any given level of activity I can figure out what my total cost is. So my total cost is 3950x plus 247, 420. Alright, let's look at another equation here, or another problem. This is 5-39 in your book. This looks very complicated. Let's stick with the purple. It looks very complicated. It's really not. They're giving us our overhead, they're giving us our fixed cost, they're giving us our variable cost, and what they want you to estimate is our total cost for this overhead at 9,000 machine hours. Well, we know how to do that, right? Our overhead equals our fixed cost plus our variable cost. We're taking our fixed cost that they give us, and we're going to add in those variable costs. Then at 9,000 hours. So if I can go ahead and do all of that math, this is 412, 470. My total overhead then is going to be 618, 939. So then you ask, what is all of this and why is it here? What they're trying to do is give you some of this information from these definitions so you get a little bit of understanding about what this does graphically and for our assumptions. So if you really want to get into statistics, you can Google these things. There's a lot out there about this, probably because it is a little bit harder to understand. For our purposes, I'm going to give you exactly what you really need to know. So this correlation coefficient is your R, right? And R tells you how close you are to the line, right? So R tells you how close your data points are on a line. That's really all it's looking at. If R is closer to 0, there's no correlation, meaning we can't find a relationship. If R is closer to 1, or if it is 1, it has a perfect correlation. So what you really want that R number to be is closest to 1. The R squared, it kind of does the same thing, but that's looking at how far those data points are off your line to say, based on this, what can I predict these relationships to be? So it's more of a predictor. So let me kind of show you what I mean. So here's our graph, and a lot of this is looking at that scatter graph method of estimation. That's more of what it's used for, which we don't really get into because you do need some programs to do that. But let's take a look. If R was, let's say, 0.1, your line would look something like this. Because our goal of our line is to draw right in between where the points on the graph hit. As you can see, our points are all over the place, so it's hard to find that correlation. Whereas, if I then look at, I'm running out of space. I made that too big. Let's just go with a different color. If I look at this graph, and I say, here's my line, and here's my points. Maybe there's even one on the line. This means, let's say my R is closer to 1, which may be 0.9. That means it has more of a correlation. I can find something in common in how my X and Y are related and what that effect is going to be. You're not going to be asked to calculate this or anything like that. Just again, be aware of it. How is this going to affect that scatter graph method? And how does it affect what we're looking at when we are estimating those differences with your variable and fixed costs? So, and what that correlation is. So just that's all you need to know. Don't get too wrapped up in this unless you really want to and it's really interesting to you. All right, so moving forward. Oh, and just one more thing. So that R squared, we're looking at that distance from the line. How far are we getting? All of our data points, how far are we getting from that line? Again, that's about as far as you need to get for this class and these terms. Let's move on and look at a different problem. This is 5-49. What we're looking at here is that learning curve. We all have learning curves. This should be a little bit more familiar to you. I mean, just think about starting this class and opening up Blackboard. How much time it took you to find everything you needed, learn what your assignments were, how to do each of them, what was actually due this week, how much time it took to connect with your peers, and then look at the second week and everything gets a little bit faster, a little bit easier. Third week, maybe the material's getting a little harder, but you've found new steps to make it easier to study. So that's what this is looking at, is that learning curve. So when we go through this, we just want to know, well, how much less time is it taking me to do this? So we're trying to find that correlation or the differences as we get better at doing anything. So you can see here, I took 8,000 hours. I'm going to simplify and cut out those zeros. Where it used to take me 10,000 hours for the second item. That's an 80% decrease in time. If I look at the next one in 4, every time I double, I'm getting better at this. So that took me 6,400 hours compared to that 8,000, which is again an 80% increase or decrease in amount of time. So what it appears to do is tell me that every time I double the number of units I've made, I am experiencing an 80%, only 80% of those hours are needed to make the same doubling amount of that product. Easier said. So let's look at what this means. I'm going to carry that 80% forward to these next line items and say, if it only took me to make 4 units, it took me 6,400 hours. I'm going to take that 6,400 and multiply it by 80%. and I would get 5120. So that 5120 is going to go here. That's how many hours that one would take me. And then for the 16 units, I'm only going to take me 80% of that, which equals 4096. And that number would go here. So now I know how much time it's taking to produce both 8 units and 16 units. The question is, how much money is that saving me? And as a manager, that's what you really want to look at. So we're going to look at how much it costs me to make that first unit versus how much it costs me to make the 16th unit and what effect that had. So for that first unit, it took me 10,000 hours to make this unit. It cost me $125 per hour, which is a lot of money. So that's my first unit. When I come down to that 16th unit, that's when it's going to only take me 4,000 hours. I still have to pay the same amount of money, but look at that difference in cost. That's what that learning curve is doing for you. So if they want to look at this as a percentage, which they do, what is the percentage of cost? All I'm going to do is take those two numbers and divide. So that 16th unit is only costing me 40.96% of that first unit. So this just kind of puts into numbers that learning curve and how much more efficient we get over time. So hopefully this helps you through some of these concepts. Again, don't get scared. Let me show you again. Don't get scared over these terms. I know that they're new to most of you. As long as you can go ahead and get the problems done, that's what we're trying to do. We just want to make you aware that these terms exist and how they relate to this topic. Let me know if you've got questions.